It's my pleasure to introduce Pete Beckman from Northwestern, and he's been and we actually heard his name yesterday, I think, during the Neon talk about experimenting with AI at the edge. So one of the really cool, I'm going to opine for a second before I let you go. There's models running on my phone that are quite capable models in terms of Gemma and these other sorts of models. And these can do quite a lot without having to send data off to the web. And I think he's going to give us a wonderful talk about how we can use those sorts of models for science. So with that, thank you.
All right, let's double check that my audio is working fine for you.
We
Everybody okay?
I can hear you.
All right, so thanks for the intro, and absolutely, we're going to talk about how the world is changing, as your talk pointed out, with respect to agents and LLMs and how we write code. So let me get started because we're going to try and cover a lot in a short amount of time. So Sage Grande is a relatively new project. It's about a year old, and it's a test bed from the Office of Cyber Infrastructure to deliver a capability for people to explore AI and build new kinds of infrastructure. So it's different than, some grants in that it's an infrastructure test bed grant that lets people then bring their science and try new things. So things like next generation AI infrastructure, new AI safety and privacy techniques, new AI algorithms, and we'll be deploying 300 of these next generation nodes across the country. So what can you do with nodes or computers that are stationed out at the edge at instrument sites? So this team is the team that's bringing that together. You might recognize some of these faces, Manish and Dan Reed and Jason and Ilkay and Nicola and others. And it's a distributed team. And the idea here with Neon is an example, one of those important collaborators, a key collaborator for our project, is that right now in Neon and in other instrument sites, the data is essentially stored and then forwarded, and you can't store it all. So data samples are very small because you're restricted in what you can send. You send a little tiny average or a snapshot of something. And what we would like to do is to say, hey, if we put AI right there at the edge, at the instrument site, can we analyze all the data? And could we provide real-time analysis? And then that opens up, as Charles pointed out, this wide new space of bringing agents and LLMs to the edge. And so we'll touch on that topic. So the real concept here for Sage is how do we bring AI and put it at the instrument site and provide a new kind of infrastructure? So here's a very simple block diagram. I mean, you would draw probably the same block diagram as I have. If you had a chalkboard and some time, you might come up with the same design. It's pretty straightforward. The concept is that out at the edge, we'll have GPUs that run AI code. We'll have a repository in the cloud that can send those containerized workflows of AI codes out to the edge. And of course, we'll have supercomputers that can do end-to-end workflow that takes large data, maybe builds training sets or models. And then the way a user interacts with this could be either via large language models and prompts or by writing their own purpose-built code. And of course, we want to take best of class and use models that are already developed. There are many new models being developed, and we want to be able to field those quickly from places like Hugging Face and other model repositories, very quickly wrap them in a Kubernetes container and send them out to the edge. So it's a very simple, straightforward design. What can you do? Well, students and postdocs have worked on a variety of things from wildfire detection to predicting flooding by using and processing data at the edge. And just one simple example of that, this is a Sage node that's on a tower that is what's called a ballasted tower, meaning it doesn't have to, no one has to pour concrete or drill holes in the ground to mount this. They just bring some cinder blocks and put it on the pads here and put this tower up. And this is out at a water site, a aquatic area for birds. It's solar powered, and it can then run the Cornell bird model. Now, this is the standard bird model that you would find on your Merlin app if you have this on your phone. So those local models, whether it's Gemma 3 or it's specialized models like Merlin, can run on Sage nodes. And those Sage nodes can then identify in real time without sending all of the data, all of the audio back. It can do real-time AI processing and return new results or identify things that aren't in the data set yet. So this is an insect chirping, or this is rain. These things are not in the Cornell data set yet, but could be extended, right? And it could provide new capabilities. So just to highlight that before we move on to some of the LLM and other capabilities, is Sage is a test bed. So that means you're invited to try it out. It's a NAIR pilot resource. You can bring your computer science problems. Hey, I want to do some LLM benchmarking. I want to look at cybersecurity or privacy enhancing technologies. We have a student, for example, Manish Parashar, student at Utah that's working on privacy enhancing technologies, and the University of Illinois Chicago folks are working on automatic face blurring for nodes. These are research projects that you can do, I'll say, in reals, not as a simulation where you've downloaded some images and trying it on your laptop, but you could really deploy this and try it out in the wild. Or if you're a domain scientist and you want to build interesting new instruments that have AI capabilities or agentic capabilities, you could do that because it's a test bed. So everything from we are steering a LiDAR, we had a project that steered a LiDAR in Nantucket to looking at infrared cameras for hotspots from wildfires and fires in Oregon. So I'll give you two examples now of how those large language models could be pushed out to the edge and what that might do. So this is something we worked with the University of Hawaii to deploy some nodes in Volcanoes National Park. Now, this is one of the scientists from Hawaii, and this has a GPU in it. So it's now able to process and run models literally at the edge on a tower. And these are students who helped get there and put those nodes in place. And so what can you do with this? Well, you could go to the Sage website and look at this, but here is an example of all of the apps, the AI apps running on that node at the edge. And then some students from University of Hawaii of Jason Lee's wrote some code to say, hey, if we used an AI model at the edge, in this case, Moondream, could we caption each image and then detect if the volcano is erupting? Now, this is not a data set that's already been coded. This is using a model like Moondream or Gemma 3 or others and saying, well, can that model be helpful in determining if a volcano is erupting? The volcano, in this case, on Kilauea. And so it is, and surprisingly, and maybe in a fascinating way, a very simple query, is there a fire, right? Is there a volcano eruption in this image? Can reply yes and snap a picture of it here. And this is using LLMs with a no-code approach, right? So this is just being able to write a query that goes into a prompt that then runs at the edge. Now, this is developed into some future features. This is from the U.S. Geological Survey. We don't have a camera that close to the volcano, but there was a recent eruption on Kilauea, and we're seeing it from a distance here, and we're seeing it at night on the infrared camera. So here is what it looks like. You can't see anything in the naked eye at night, but you can see the heat from the volcano and the eruption here in this plume. But this is the interesting thing. The students hacked the feed, a real-time AI feed, into Discord. So they have a Discord channel that sends them updates when there is a volcanic eruption. Is there a natural disaster? Yes, the image you provided shows a volcanic eruption, right? So this is again an AI model being explored. It's not perfect yet, as it was pointed out. There are problems with the accuracy and precision, but that's why test beds exist, is to explore these ideas and to let students try new things. The same is true. We've had this project with University of Wyoming at Grand Tetons. I'm just highlighting two nodes to give examples. And this particular node is interesting in that it has a very powerful pan tilt zoom camera that has a 30x zoom. So it can look 360 around, but then it can identify things using AI to explore. So here's an example of that code running. So here's a standard picture from the pan tilt zoom camera up in the upper left. And you can see here that it's catching a little bit of the pole. That's where it's mounted, but it identifies an animal next to the lodge here. And then autonomously, based on code that's written for the agent controlling the camera, can zoom in. So you can imagine, maybe this is a bit sci-fi here, right? Is looking and having curiosity to find new things that it hasn't seen before, zooming in and getting better images and then captioning those. So here's the first image, and then it zooms in and gets a closer image. Here's some examples taken at night of elk surrounding nearby. And in this image here, there's even a tag in the ear. So this elk has been tagged before. So you could imagine reading those tags and even being able to do even closer inspection. But again, all autonomously with an agent that you've written for the edge, not a human in the loop steering things. So making this kind of data broadly available gives us a new way to query and ask questions. That data is available now. We have some early prototypes. This is a simple query asking the database of all the data that's come in off Sage. Hey, find me pictures of birds, right? Now, the fun one, the reason I show this one is here is a real bird. And that is not a bird. That happens to be the anemometer, the wind speed detector the camera's looking up, but the propeller on that kind of looks like a bird. So you can see where AI is making the best guess, and that is happening out at the edge. And that is now being run as infrastructure using, Pelican, OSDF, and the National Resource Data Platform and National Research Platform, Condor Resources, so that those things can be part of institutional computing. And as I start to try and wrap up here, so we have some questions, I'll point out that another place that Charles mentioned, and I'm sure others have mentioned, is that people are now writing code using AI assistants. And Sage Grande has an MCP prototype that you could plug into, in this case, for example, Cursor. You plug that in, and then you can start to just ask questions and write code by using natural language. And so what can you do? Well, you can do a variety of, these are examples, right? You could say, hey, show me all the Sage nodes and their sensors. Find plugins that monitor bird sounds. You could, ask it to write a plugin, and that's been successful. Write a new piece of code for the edge that does the following. Compare bird activity between rural and urban nodes, right? These are all now questions that you could ask, and then use as Claude or ChatGPT as the backend to fulfill those questions and interact directly with Sage using your credentials. Okay, now that's a scary one, but that's what research platforms and test beds are for. It's to try those ideas out, and you can let them be autonomous in that way. So we have a variety of nodes already out there. We're deploying Thor-based nodes right now. The Thor is a Blackwell architecture GPU that's designed for the edge from NVIDIA. It's very powerful. Has 128 gigabytes, which means it'll hold a very large language model for you out at the edge and let you explore agentic and LLM capabilities. We've had a virtual workshop that allows people to get on and try stuff out. You could go today and click the Get Started button and start trying to ask for an account and get on. Remember, it is an open test bed. I'll summarize with this slide, and then we'll have a little time for questions. Is remember that Sage, like other NSF infrastructure, this is a cyber infrastructure workshop, right? This is about infrastructure that lets you do science. So Sage is a test bed to run your AI. The team providing the cyber infrastructure isn't writing the AI code for you. That's something that you get to do. So bring your students. As I said, there are students who are working on privacy preserving technologies. There are students who are working on detecting wildfire, hooking to Discord channels, and doing automated notifications. So there's room here to run your own LLM at the edge, to explore AI agents and autonomous control. That camera is just one example. There's another other autonomous agents you could explore. We're also deploying over the next few years 300 nodes. And if you had a place, we've had several new groups come forward and say, hey, we want to deploy some nodes specifically to explore our science. We'd love to talk to you about that. You can get on either Slack or email or go to the Sage website and then connect from there. So with that, I'll have some time for questions, and we can discuss what's up.
Thank you. So, yeah, let's take some questions from the audience here. Uh,
Oh, I see somebody from Roosevelt University in Chicago on the chat. That's great. By the way, there are Sage nodes that are in Chicago now, and several projects at University of Illinois Chicago that we could talk about as well. But yeah, we should please let us know. We'd love to chat with you. You can contact me or send mail to that support number, support email, and we'll follow up.
I think Ava has a question here.
Yes, so thank you for your presentation, Pete. It's always very interesting. And I love the fact that we have this test bed that we can use for a variety of experimentation. As you know, I work in issues of resilience. And so, when I see test bed, I see opportunities to bring stuff down and see how the cyber infrastructure reacts to that. And so I was wondering, can you inject faults and take down some of your infrastructure and bring it up automatically, or is it, something maybe in the plans?
No, that's a good question. And uh, it is a very important topic for us, this fault and resilience piece, because many of the nodes get deployed in places that you get to visit once a year. So, you know, one example is on a street pole in Chicago, that requires shutting down traffic and sending a bucket truck out to get up there. So in the node, there are a set of resilience features that automatically reboot it, try a different operating system kernel if the first one is failing for some reason, and so forth. So there are opportunities to use that framework to inject, I'll say, problems or to try things out. The other thing is that the design is such that nodes can be separated from the network, sort of disconnect from the network for a period of weeks, and still then, when it does connect, upload all their data. We have nodes that are Starlink connected, that are cell phone connected, and networking problems happen. And so that kind of resilience is a place that could be explored as well, and understand, how to maybe automatically reduce data to match the right bandwidth that might be available at any given time, other things.
Great. Thank you so much.
Okay, I think we have one last question that I think could be answered briefly, and then we can move on. Are there any healthcare examples, or have you thought about healthcare for the
Yeah,
Sage platform?
no, it's a very good question. I'll answer briefly. We don't have any yet. We have talked to some people who are interested, specifically, what can be done in a privacy preserving way to, I'll say, understand situations that are happening possibly in the home or other places. Has someone fallen, right? That's a very simple not totally simple, but it's an
It's a
example of being
tractable
able to
problem.
say
Yeah.
it's a tractable problem.
Yeah.
Is there someone laying on the floor who maybe hasn't moved in 30 seconds or a
Yeah.
minute because they've fallen? So these are research topics that I would love to see people explore and
Mhm.
try with Sage.
Okay. All right. Well, thank you. That was a very, very enlightening talk, I think.